Question 1. Some students investigated the reactivity of 4 unknown metals, W, X, Y, and Z. The letters are not the symbols of these elements. The students used metal salt solutions of copper nitrate, magnesium sulfate, and zinc chloride. This is the method used. Okay, so got a method there. The students did the experiment using each salt solution in each metal. There's what the apparatus looked like. The table below showed their results. Okay, and so first question: which metal is least reactive? And tick one box. Okay, so one of these metals is least reactive. Which one is it? Well, we're looking for the reaction where nothing happened at all. So so it looks like so nothing happened with the with Z, metal Z, otherwise, because it wasn't able to steal the nitrate from copper, it wasn't able to steal the sulfate from magnesium, or the chloride from zinc. So without a doubt it's going to be metal Z. Oops, sorry, tick there, so metal Z. Okay, because there's no change, it wasn't able to displace any of the metals from the solutions, the salt solutions. How do the results show that magnesium is more reactive? So magnesium more reactive than metals W, X, Y, and Z. Okay, so let's have a look at the results. So how did the results show that magnesium was more reactive? That's worth 1 mark. Well, so we don't know what the metals were here, but what I can see is magnesium is mentioned there, and magnesium sulfate did not react at all with any of these here, which means that none of the other metals were able to displace magnesium from the sulfate, so they weren't able to steal the sulfate from magnesium. So magnesium sulfate did not react. Magnesium sulfate. Remember, the most reactive metal, the more reactive metal, will displace a less reactive metal. So if no reaction happens, the more reactive metal is already with the salt. So if this was an explain question, I would certainly add magnesium sulfate did not react. I'd certainly add that this means that the other metals were not able to displace the magnesium. Did not react with any metals. It's only a 1 mark question, so that should be fine. How do the results show? How do the results show that the reaction between metal Y and copper nitrate solution is exothermic? Okay, exothermic, remember, heat released, heat exits. So what happens? So we're looking at metal Y, which is here, and copper nitrate. So the result for that is there, it's 29. So this is the temperature increase. Okay, so the temperature increases. Temperature increases. Part D. One student said that the investigation was not valid. Okay, so they're saying it's not a fair test. Write a plan. So write a plan for the investigation that includes improvements to the method and apparatus for 4 marks. 1, 2, 3, 4. So how do we make sure that it's valid? Fair test in particular, we're looking at control variables. How do we make sure that we've explained what things to control? Okay, so we've got the method, we've also got the apparatus as well. So how do we, what can we do? So there's the method. So pour a solution of metal salt into a glass beaker. So we're looking at here how much, in every case, how much. So pour a solution. Well, so let's put the quantity, the volume. of a metal salt into a glass beaker, measure the temperature of the solution, add 1 gram of metal to the solution, measure the temperature of the solution, calculate the temperature increase. Okay, so other things we could be doing there is we could make sure we could stir it there to help. Okay, we need to make sure that not only the solution, the quantity and concentration, maybe even the start temperature. We're calculating the temperature increase. Well, what about all that energy? What about all that temperature that's lost? So maybe we need to insulate as well to try and keep that that temperature in there. When should we measure the temperature of a solution? Okay, at what time? Is it fair to do a time, or should we perhaps should we just measure the maximum temperature it reaches? Okay, so let's think about how we might write those. So, write a plan for the investigation. So we're going to pour, so there's 5 steps at the moment, so we're going to pour we can make up numbers here if we want to. Pour the same volume, or we could just say the same. Let's not do that actually, let's say how much. So we're going to pour, we might do 20 centimeters cubed of, it says the solution of metal salt. Into a glass beaker. We're going to measure the temperature. So I'm just going to copy these. So measure start temperature. Of solution. We're then going to add 1 gram of metal to solution and stir. So how many times should we stir? So we're going to make it's not just stir, we're going to say exactly how many times you do it, and stir, I don't know, 5 times. Same. Okay, what are we going to do then? We're going to measure the maximum temperature. So reached of the solution. So it's not just measure the temperature, because we could say after a certain amount of time, or we could an easy one is just say the maximum. Where are we at now? Step 5. Calculate the temperature increase. Okay, I'm happy with that. Now, temperature increase. So I'm copying quite a lot of what it's got. I've just improved a little bit. So this is my method. So I might even put steps 1, 2, 3, 4, 5. I've added bits to each of them. And then I might say here controls. Control variables. Okay, so what extra things are we going to do? Or improvements. So other things I need to do is I need to keep concentration of salt solutions the same. I can't have one that's really strong and one that's not. Anything else I said on there? I've got to keep the start temperature of all the concentrations the same. Temperature of solutions the same. Okay, and the other one was I was going to insulate. So insulate the beaker to avoid heat loss. Start temperature of the solutions, actually think about it, I was going to do the start temperature of the solutions the same, but actually the room temperature the same as well. So this is quite a lot I'm writing here for 4 marks, and you probably wouldn't need to write them all, to be honest. The key bit here is that you've got the the key bit is you've got the method here, and you're identifying some control variables. The bit I might suppose in my method here, I might have said into an insulated glass beaker would probably be better than writing it down here. But as long as you've got it somewhere, that's fine. Okay.